Hello and welcome to the deep dive session on Amazon Bedrock model customization. If you are new to AWS or want to enhance your skill on AWS AI services, this session is for you. This video is part of the AWS certified AI/ML bootcamp series. On behalf of the CloudExpert Solution team, I would like to thank you for joining us and exploring this video. Let's first review the topics we are going to cover in this video. We'll start with Amazon Bedrock model customization deep dive, followed by we'll discuss Bedrock fine-tuning. Then we'll discuss distillation. This is a new feature and the feature is available in preview. As of now, since the feature is in preview, so don't expect any questions for distillation. However, it's crucial to understand the concept and how distillation can help us in model customization. Then we'll log into AWS Management Console and we'll review Amazon Bedrock customization in action. Followed by we'll discuss fine-tuning use cases. Then we'll review how to prepare the data for fine-tuning. And we'll discuss single-turn messaging, multi-turn messaging. Then we'll move to continuous pre-training. This is another one type of model customizations. And we'll conclude today's video after discussing transfer learning. We have a lot to cover. Let's jump right into it. Model customization is the process of providing training data to a model in order to improve its performance for specific use cases. Imagine you have a general purpose language model, maybe Amazon Titan Text G1. This model can answer questions about many topics. But you want the model to specialize in healthcare. That means it should answer healthcare related questions. To become an expert in medical terminology, you need to further train the model with medical journals and patient records. Once you train that model, then the model becomes specialized in healthcare. You can customize Amazon Bedrock Foundation models in order to improve their performance and create a better custom experience. Please remember, all foundation models available in Amazon Bedrock does not support customization. As of today, Amazon Bedrock supports two types of customization. One is fine-tuning and the other is continued pre-training. For fine-tuning, we used labeled data, whereas for continued pre-training, we used unlabeled data. Talking about data, for the model fine-tuning, you need the data to train or customize that model. As of today, Amazon Bedrock provides a capability called distillation. As I mentioned earlier, distillation is still in preview, and using distillation, you can generate synthetic data from a large foundation model. Once you have the data, you can use the synthetic data to fine-tune a smaller model for your specific use cases. The model from which you are generating the synthetic data is called teacher, and the model to which you are applying the synthetic data is called student. Now let's review Amazon Bedrock fine-tuning. For fine-tuning, the first step is you need to choose a model from the list of available foundation models in Bedrock. And as we mentioned earlier, not all foundation models can be fine-tuned. In our demo, we'll review what are the models that is available for fine-tuning. Currently, Amazon Bedrock supports only one model per fine-tuning job. If you have a requirement to fine-tune more than one models, then you need to create multiple fine-tuning job for you. When you are selecting a foundation model for fine-tuning, Amazon Bedrock always creates a copy of the selected model, and the copy of the model will be available only to you. Amazon Bedrock encrypts your custom model's artifact by default with a AWS managed key. But if you have a requirement to use a customer managed key, then you can create a customer managed key in KMS, and you can optionally use that customer managed key for encrypting the model's artifact. To train a model, we understood that we need two sets of data. First set is training data and the optionally validation data set. For AWS Bedrock fine-tuning, the training data set and the validation dataset, if you have, it must be stored in an Amazon S3 bucket. As of today, you cannot upload data from any other sources other than Amazon S3 bucket. And training data and the validation dataset must be in a specific format. We have dedicated slides to explain that specific format and the requirement, because that is very important to understand. But here is a sample. For a text-to-text model, each training and validation data in the dataset must be a JSON object, and it must contain both a prompt and a completion field. Let's review one example. Let's assume that I have my base foundation model, which is Amazon Titan Text G1. I have uploaded my training data and the validation dataset in Amazon S3. Then I am using the training dataset to fine-tune the base model, and once the fine-tune process is completed, I will get the fine-tuned model, which can be used for my specific use case. During the fine-tuning process, you have option to customize the hyperparameters, that is in terms of steps, epoch count, batch size, and also learning rate for that foundation model. Please remember that you must purchase provision throughput to fine-tune and use fine-tuned models in Amazon Bedrock. This is very important from AWS certified AI practitioner exam point of view as well. Now let's log into AWS Management Console and let's review Amazon Bedrock model customization available options. I have logged into AWS Management Console and I am at Amazon Bedrock landing screen. For model customization, you can locate model customization from left hand side under Foundation Models, and here is Custom Models. Let's click Custom Models. We have three different options or sections in model customization. First is fine-tuning, then continued pre-training, and the distillation, which is still in preview. To start with fine-tuning, we use label data in order to train a model to improve performance, and for continued pre-training, we used unlabeled data. So fine-tuning is a supervised learning, and continued pre-training, it is unsupervised learning. Let's review how to create a fine-tuning job. First, we'll click on the create fine-tuning job, and then you need to first select the model. Now here you can see all the models are not available here. Currently Amazon, Cohere and Llama models are available for fine-tuning. However, I do not have access, or I haven't enabled access for meta models. That is why meta models are not available. But you can refer this text. Can't find the model you are looking for? See all the models here. If you click here, it will take you to AWS documentation. And here you can see all the foundation models available in Amazon Bedrock based on the region. And then it has the input modality, output modality, streaming support and all. If you scroll further, then you can see these are the models that is scheduled for depreciation because these are old models. Now let's go back to AWS Management Console. And now let's assume that I want to fine-tune Titan Text G1 Lite, which is a text model. Now I'll select that model. You can provide a name for the fine-tuning, and here is the model encryption. If you click on the info, it is saying Amazon Bedrock encrypts your custom model artifact by default with a key that AWS owns. That means it's by default encrypt with AWS managed key. But if you want, you can create a key in Amazon KMS and you can use that key. So you can select that model encryption and you can choose the key or the key ARN that you have created in AWS KMS. I don't need a model encryption using a custom KMS key. Then I'll go to job configuration. I have to provide a job name. Please provide any name you want. Tag is optional. Next is VPC setting. If you have an use case to connect Amazon S3 privately, then you can use the VPC configuration. Now coming to input data, here you can see you can provide that input data from S3, and here is the S3 bucket location. You can select that S3 bucket. You can have an optional validation data set. You can put both the training data and the validation data in one S3 bucket, or you can choose two different S3 buckets. Now please pay attention here. The file you are chosen must be in a dataset format. Now let's have a glance. So here are the dataset format. If you want to do fine tuning for text to image model, for text to text model, these are the specific format that your training dataset and the validation dataset should be. We'll go back to AWS Management Console. Now here is the hyperparameters. You can control the epoch value, batch size, learning rate, and also the learning rate warm-up steps. The output data location, you can choose a S3 location to store the model validation outputs, and then the IAM role, since you are going to store that output data to an Amazon S3 bucket. That is why Amazon Bedrock customized job will require permission to write data to Amazon S3 on your behalf. That is why you have to provide the service role name, and you can create a service role in AWS IAM and you can provide that role name. Now here is the important point. You need to purchase provision throughput to use the foundation model. If you remember, in our PPT we explained that this is an important step. If you want to perform fine tuning, then you need to purchase provision throughput for Amazon Bedrock. Once you have provided every details, then the next step is fine tuning job. Till this point, AWS will not charge anything, but the moment you will create a fine tuning job with all the parameters, AWS will start charging you for the fine tuning job, and you need to purchase the provision throughput. I do not have an use case, that is why I don't want to purchase any provision throughput. I'll go back to model customization option and let's review continued pre-training. We are going to explain fine tuning and continuous pre-training in greater depth, but let's review the option first. So for continuous pre-training job, you need to select the model. Again, here you have options. You can see the co here is not available for continuous pre-training, although it was available for fine tuning. Please remember, all foundation models are not available for customization. Then the next step is job configuration. You need to provide a name. Similar setup for input data. You need to use S3 bucket location. If you have a validation dataset, please use the location where you have the data. Again, the same configuration for hyperparameters, epochs, batch size, learning rate, and learning rate warm up. Then if you want to store that output data to S3 bucket, please provide. This is not an optional field. You must provide the output data location and then the service role. And again, for any model customization, you need to purchase provision throughput. So in terms of option, both fine tuning and continuous pre-training are exactly same, but it has two different use cases. And now let's review what are the use cases where you should use fine tuning versus when you should use continuous pre-training. Model fine-tuning has endless use cases. For example, in customer support, you can fine-tune a model to answer FAQs for your e-commerce website. You can also design a chatbot with a particular persona or a tone or geared towards a specific purpose. As an example, you can create to assist customer or maybe crafting advertisement for you. In terms of marketing, you can train to write content in your brand's voice. In healthcare industry, a hospital can fine-tune a model to predict patient outcomes based on historical data. A radiology clinic can fine-tune an image recognition model to detect anomalies in X-rays or MRIs. In terms of fraud detection, an e-commerce platform can fine-tune a model to detect fake reviews or fraudulent accounts. On the other hand, a bank can fine-tune a model to identify suspicious transactions such as unusually large withdrawals or purchase from a high-risk locations. These are just some examples, but as I mentioned, the possibility is endless. Now let's review the fine-tuning data preparation. As we discussed, for fine-tuning, it must be in a specific format and it must be stored in Amazon S3. We reviewed that fine-tuning is a supervised learning. That is why it requires label data. Now, when you are talking about label data, let's review an example. Maybe we will take fine-tuning for text-to-text model. In this case, each data object must be in a JSON format and each sample must contain prompt and completion. This tuple should be available. And here is an example. You can see for each data set, for each JSON, there are two components. One is prompt, the value of the prompt, and then completion, the expected generated text that the model should generate. And here is an example prompt and the response. Since this is a label data, that is why I provide what is the prompt and what could be the corresponding answer for that prompt. As an example, if you are putting what is AWS as prompt, then the completion could be it's Amazon Web Service. So here you are not only setting the tone, you are giving an example how the response it should generate. On the other hand, if you want to fine tune a text to image model or image to embedding model, in that case, each sample must have the image reference and caption field in the dataset. And here are the examples. You can see for text to text versus text to image, it's totally different, because when you are generating image from text, then you need to provide the image reference and the corresponding caption. Now let's review a real life example. If I want to train the model to generate an image of orange cat with white spot, then I have to give a sample image of that cat with white spot. And in that case, the sample image URL will be image reference and the prompt will be given as caption. Now let's review the instruction based fine tuning, and Amazon Bedrock supports two types of fine-tuning approach. One is single-turn messaging and the other is multi-turn messaging. In single-turn messaging, we train the model on individual prompt response pairs. Single-turn messaging is useful for tasks where context contains single interaction. Moving to multi-turn messaging can be used to train the model on conversations with multiple back and forth exchange. If you want to build a chatbot, you need to use multi-turn messaging. Multi-turn messaging can be useful for more complex tasks where context from previous message is important. Now let's review some examples for the messaging. Now let's review the single-turn messaging template. Here is a sample messaging template, and now let's break all the components one by one. The first attribute is system, which is an optional attribute. With system, you can provide a string that contains a system message which sets the context for the conversation. We'll review with an example. The next attribute is messages, which is nothing but an array of message objects, and each message should contain one role, and the role could be either user or assistant, and the content, it will be the text content of the message. Now let's review the rules. The first rule is the message array must contain two messages. Then the first message must have a role of the user and the last message must have a role of the assistant. Now using that field and rules, let's convert this template to an actual example. Maybe in terms of system message, you can set the context with you are a helpful assistant, and in the message, as we mentioned, the first message, it should be a user. Then the context is what is AWS? That means user is asking a question, and the assistant can provide an answer. It's Amazon Web Service. That means it is providing the response. Like that way, you can create all the test data for singleton messaging using this template, and you can use this test data to fine tune your base model. Next is multi-turn messaging template, and here is an example template. Please pay attention to this messaging template. The messaging template is almost same, except in messages it has now more than one set. In singleton message you saw there was one set, one user, one assistant, but for multi-turn messaging we have multiple set of conversations or the follow-up conversations between user and assistant, and one will alternate after that. So in terms of field, the field is exactly same. It should have a system which is optional, where you are going to set the context, then the message, and the message object will contain a role which will be either user or assistant, and the content for that particular message. In terms of rule, the first set of rule is exactly same, but only multi-turn messaging has one additional rule, and the rule is message must alternate between user and assistant role. In singleton, since it has only user and assistant, But here we are using multiple sets. That is why you should have user assistant, and it should come in alternate manner. Now let's review with an actual example. Maybe in system, again we are maintaining that you are a helpful assistant. In the role, here the user will start hello there. For that the assistant might reply with hi, how can I help you? And then the user might ask what are LLMs? Then the assistant might reply LLM means large language model. By that way you can power a conversation where the context of previous discussion or previous chat is required. Since we have reviewed the fine-tuning, that is the supervised learning with label dataset, the next is continuous pre-training. As the name suggests, continuous pre-training, it involves updating a model with new data over time to keep the model relevant and accurate. For continuous pre-training, we used unlabeled data for the model training. Continuous pre-training is also called domain adaptation fine-tuning. Please remember this word, domain adaptation fine-tuning. During the certification exam, if you see any terminology with domain adaptation fine-tuning, your answer should be continuous pre-training, or the question is hinting towards continuous pre-training. With domain adaptation fine-tuning means we want to make that model proficient in specific domain. Now let's review how continuous pre-training works. So the first step is data collection. Here we gather a large set of unlabeled data relevant to your domain. As an example, you can collect a vast amount of medical records, patient interaction and healthcare article as your test data set. The next step is pre-training process. In this pre-training process, Amazon Bedrock continuously pre-train the model with the data in a secured and managed environment. And as a result of continuous pre-training, we have the adapted model. Now the model learns from the new data, improving its ability to handle domain-specific languages and tasks. As an example, now the model becomes more proficient in understanding and generating text related to healthcare, which makes it more useful for tasks like summarizing patient record or gathering medical reports. In terms of benefit, first is domain-specific knowledge. The model becomes more knowledgeable about your specific domain where you want to deploy this model. Second, improved performance. It will enhance the ability to handle out of the domain data and generate more accurate responses. And last but not least, customization. Now the model will be tailored to reflect the terminology and style of your own business, since you have pre-trained the data with your domain-specific knowledges. Now let's compare fine-tuning versus continuous pre-training. Fine-tuning involves training a pre-trained model on a smaller domain-specific dataset. But for continuous pre-training, since this is an unsupervised learning, it involves updating a model with a large amount of new unlabeled data. As a result, fine-tune requires intermediate ML skill, whereas for continuous pre-training, you need advanced machine learning skill because you need to understand the domain, you need to understand and collect the dataset for the pre-training. Fine-tunings are relatively quick to set up, especially if you are using a pre-trained model, whereas for continuous pre-training, it's a longer setup time because of extensive data collection and pre-processing. Because of extensive data collection and pre-processing, continuous pre-training require longer setup time. Fine-tuning can be completed in hours to days. That depends on the data size and the model complexity. However, for continuous pre-training, it can take weeks to months, and that depends on the scale of the data and the model size. And last but not least, fine-tuning is cost effective, whereas continuous pre-training is significantly more expensive due to the extensive computational resource requirement. Now by this time, we have understood that training a new machine learning model is time consuming and intensive process which requires large amount of data, computational power and several iterations before it is ready for production. That is why we can use a foundation model and we can customize on top of that. Now in this slide, we are going to discuss transfer learning. Transfer learning in Amazon Bedrock involves taking a pre-trained model and adapting to a specific task or domain using a smaller task-specific dataset. Let's take an example. Let's say you want to create a customer support chatbot for an e-commerce website using Amazon Bedrock. The first step is pre-trained model selection. You can use a pre-trained language model available in Bedrock, which is trained on general conversational data. Then the next step is task-specific data. You need to gather a dataset of customer support interactions, including common questions and answers related to your product and services. Then you need to upload that customer support data to Amazon S3. And the last step is fine-tuning. You can use fine-tuning feature in Amazon Bedrock to train the model. Then you can fine-tune the pre-trained model on this dataset to adapt it to a specific language and context of your customer support interactions. Please remember, fine-tuning is a specific type of transfer learning. So transfer learning is the superset and fine-tuning is one specific type of transfer learning. In terms of benefits, first of all, it is efficient because it reduces the amount of data and computational resources you need compared to training a model from scratch. Then performance. It provides better performance on specific tasks due to the model's prior knowledge because you are selecting a foundation model which is trained on general conversational data. On top of that, you are adding or fine-tuning the performance with additional detail. That is why in terms of performance, it will be always better rather than training a model from scratch. And last but not least, speed. Since you are already using a pre-trained model, it will be faster to deploy as it is leveraging existing pre-trained models. Please stay tuned and explore other modules from the Bootcamp playlist for a comprehensive understanding of the topics required for the certification. That wraps up this module. If you found this video helpful, please give it a thumbs up, subscribe for more update, and feel free to drop any question or feedback in the comments. We would love to hear from you. I hope this session helped you gain a deeper understanding and brought you one step closer to your learning goals. Thank you very much for watching and learning with us at CloudExpert Solution. See you in the next module.